It's such a thrill to have all of you here. Let me introduce each of you individually and maybe ask you a quick question, then we'll have a conversation. We'll try to also open it up at the end to invite the room to participate in this conversation. Lila, let me start with you. Lila happens to be one of my colleagues at Google, but Lila is the Chief Operating Officer at Google DeepMind. She's had a remarkable career both at Google DeepMind, helping to scale our operations and how the place works and how we build these extraordinary things that we're building. But she's also had 3 decades of work in technology, building and scaling things. She was at Kleiner Perkins, she was at Coursera, and in fact, fun fact, Lila was actually one of the people who was in the inaugural Times 100 Most Influential People in AI. She was on that inaugural list. And actually, she shares a distinction with Van together. We'll come back to that in a second. But Lila, Google DeepMind has been at the forefront of using AI to advance a lot of big scientific questions. Can you talk a little bit about the role that AI is playing and give us some examples of what you're most excited about?
Great, thanks, James. Yeah, we believe that AI could be one of the most transformative technologies of our time. And as James mentioned, it's why I chose to come to Google DeepMind a little over 6 years ago after 3 decades in tech, because I felt that this was the place to build AI responsibly to benefit humanity. Imagine if we could use AI to unlock our understanding of the universe. Like, what problems could we help address and solve for humanity? Think about the life sciences, Alzheimer's, Parkinson's, malaria. Or what about in dealing with industrial waste in the environment, plastic-eating enzymes? What do all of these things have in common? They're all protein problems. And so 3 years ago, this is where Google DeepMind's AlphaFold advanced AI system came into play. We solved a 50-year grand challenge of how to predict the 3D structure of a protein. Now, why is that important? Not just to mention the examples I just gave, but if you can go back to your high school classes, proteins are the basic building blocks of life. And if you can predict how it's going to fold, you can predict the function, you can also predict how it might misfold, and therefore what's wrong. So with our AlphaFold AI system, we were able to basically put together a database of over 200 million known proteins, all of the ones that are known to humankind, into a database provided to researchers worldwide. There's about 2.2 million researchers in 190 countries using this database today. They're using AlphaFold to advance work in the life sciences and sustainability, and so many food security, so many different applications. And what's significant about this is it used to take a researcher about 4 to 5 years to understand a single protein. You had to have the right equipment, the right knowledge. It took time. So we think of it as like we've basically taken 1 billion years of scientific advancement and discovery and condensed it and made it freely available. And I think this is really significant because of what this is going to be unlocking for the world in the coming years, as well as the researchers are making advancements. And it's just one of the very many things in our portfolio around AI for scientific discovery and advancement. We like to think of it as how do we do science and at digital speed?
Yeah, no, I actually think that's remarkable. What I find particularly remarkable, Lila, is that in addition to proteins, you've now extended this to all of life's biomolecules, whether it's DNA, ligands, RNA, and all of that, and also their interactions with each other. I was actually quite struck, by the way, I was in Brazil a couple months ago, and of those 2.2 million biologists who are using this, I think something like 18,000 are actually in Brazil. So the inclusive aspect of this, how it allows everybody to participate, is pretty extraordinary. But we'll come back, because you did some extraordinary work as well to think about how do you ethically do that and how do you involve others. But I want to come to you, Anima. Let me first introduce Anima. Anima is a Bren professor of computing and mathematical sciences at Caltech, and has done some really important work in AI on these things called neural operators. But it's a really deep way to understand how you can build AI systems that allow you to do science in extraordinary ways. So your work has been applied in so many different areas, from climate to cancer drugs. In fact, some of them are actually in actual cancer drugs today. But talk a little bit about how you've thought about applying, first of all, developing the technology, but also applying it to some of the biggest challenges that we've got.
Yeah, absolutely. And just to kind of go back in terms of when I arrived at Caltech, it was such a hugely inspiring place. And if you saw John Hopfield did his foundational work at Caltech, right? And it was really this course called Physics of Computation, where John Hopfield, Richard Feynman, Carver Mead came together. So that interdisciplinary nature has always been there at Caltech. And so when I arrived there in 2017, the question I was asking was, every scientist, how do you think AI will impact you? And at that point, a lot of the AI was working on mostly images, a bit of text was starting. And so, for them, it was like, oh, that's so far out there. I don't know. I don't see myself using it because, first of all, there's not enough data available in many of these scientific domains. And the other challenge is, if you think of many of the physical processes, there's so many fine details to capture. One of the foremost challenges we see today is how to simulate these very complex systems. So think of our planet. Think of the hurricanes that are happening today. What if we could predict them much better, right? What if we could assess their risk and say, oh, this is where we truly need to evacuate, and we need to do it soon. And so those were the challenges that I was motivated to tackle. And when I looked at the current neural networks, the standard neural networks that are used for protein folding or text models, image models, that was not enough because it was not able to capture all of the fine details. So you still needed the standard physics simulation, and you could add a bit of AI to try and refine it. But overall, it was slow, it was big. It needs big supercomputers to do weather forecasting today. And even that is not enough to do hurricanes and other extreme events well, because it takes so much computational power that we just don't have. And so what we asked was go back to the fundamentals. With neural operators, we thought of it as now a new kind of AI technique that could go and capture these fine details to any extent that you need. So think of how you have a standard image, and if you zoom in, it gets blurry, right? So it doesn't have those fine details. And that's not enough, because if you just stare at a hurricane, you have no idea where it's going. It's really that fine eddies and those details that are very different from how we think of images, how we think of the visible world. And so neural operators are able to infinitely keep refining and adding all of the laws of physics and that knowledge to make that fluid dynamics accurate. And so we had that fundamental proposal of a new technique, and then we were like, let's look at what is a challenging case. And that was looking at all the historical weather data that's out there, 40 years of well-curated data, similar to protein folding. Data is also the oil, right? So you really need good data. Having that and these techniques allowed us to build the first AI-based high-resolution weather model. And to our surprise, it not only was accurate, it was tens of thousands of times faster. So what would take this big supercomputer to do weather forecasting can now be done on a local gaming PC. And in fact, we permissively open source, so it's available for all of you to download and run it. And in fact, weather agencies around the world, including America's NOAA agency, are using this, developing further, adding further regional data, so including in the global south, a lot of regional agencies are using it. And to me, that's how the revolution in weather and climate modeling is just beginning to happen. And the same technique is not only for weather, but also for predicting how plasma moves in a nuclear fusion reactor, and if we can control that better. It's also for how we can store carbon dioxide underground in reservoirs, how much carbon dioxide would actually stay there and not escape back, right? So these kinds of really hard, challenging questions we have in being able to model these physical phenomena, and also be able to design. We designed a better medical catheter that reduces bacterial contamination by 100-fold. And in fact, that's the most common healthcare-related infection that you can get. And so, it's just, all these may seem so different, but the unifying theme is math, and unifying aspect is the ability to learn from data and physics with neural operators to make these breakthroughs.
Well, you know what's remarkable about what you're describing, Anima, is the fact that a lot of this is also starting to show up as real things to help people in the real world. I mean, so for example, some of the work that some of my colleagues have done have taken geological models and physical models to be able to do what are called predict riverine floods.
Yes.
So as climate change weather events become more extreme, the ability to predict floods is a really big deal. So in fact, we actually began a small experiment in Bangladesh about a year and a half ago to predict floods. Because it turns out if you can actually predict floods with something like 5 to 7 days in advance, you can actually really help people get out of the way and save lives and all other kinds of things. So that initial pilot in Bangladesh worked. We expanded it to the southern part of India. Today, we actually do these flood forecasting models in over 80 countries, covering about 460 million people who get flood alerts. So real people, they may never know this was AI, but they get a flood alert and understand that this helped them. But I want to change gears a little bit. So this is the Van you've never met before. So not the Van who's the political analyst on CNN and so forth. But Van, you've been pretty passionate about thinking about opportunity and how some of these technologies can transform how we think about opportunity. Yeah. Say more about that and talk about what you've been doing with Dream Machine.
Well, first of all, I'm glad to be here. Everybody is being very depressed because we've been talking about how great the conference has been. It's so amazing, and I missed all of it. I just got here this morning. So please do not say that to me anymore. I already feel sad. Also, usually if you guys see me sitting talking with a microphone, it's usually Anderson Cooper. And I'm so happy to be with you and learning such new stuff. But I think people don't know that if you see me for 7 minutes on a segment at CNN with Anderson, minute 9, I'm in an Uber, gone. I don't live at CNN. I spend most of my life working in the not-for-profit sector in overlooked communities, underestimated communities, Appalachia, black and brown communities. I spent 30 years working on bipartisan policy and trying to get kids out of jail and into jobs. And I have to say, I'm pretty disappointed in the overall outcome of the work that I've been a part of because the problems seem to be getting worse and not better. I can't point to a single neighborhood I've worked in that's any better. It's either worse or it's been gentrified. And I've been really losing a lot of hope, frankly. And the thing that has brought me back and has given me hope is actually AI. I think that's shocking to a lot of people because in my industry, we get a lot of clicks and we get a lot of attention for running headlines that say essentially, AI sucks. Right? AI is going to take your job. Right. AI is racist and hates you. So that's kind of a bummer. And but in meeting James Manyika and the conversations that we were starting to have early in this thing, meeting with will.i.am, I started to realize there's a whole other side to AI that's not being talked about. Dr. King talked about equal protection from bad stuff, and that's important. We don't want algorithmic bias. We don't want negative impacts. We do want equal protection from bad stuff, but Dr. King talked about equal opportunity and equal access to good stuff too. And there is good stuff coming through AI. And by the way, the poorer you are, the better AI is for you. AI has been almost presented to people as if it's like a hand grenade that's going to blow up their lives. It's a jetpack. It's a jetpack. If you are an African-American, 33-year-old entrepreneur in Atlanta, and you are running a hair and nail salon, what's holding you back? You can't afford a better lawyer. You can't afford a better accountant. You can't really afford what it would take to put together a great proposal for your bank to expand. So therefore, you're held back by lack of access to capital because you can't pay for a bunch of stuff. AI means it's not about access to capital, now it's about access to code. There are free apps that we are putting in the hands of African-American entrepreneurs, African-American church leaders, and African-American community leaders that are literally exponentially, in a weekend, changing what they're able to do at the grassroots level. If everybody says, oh my God, AI, it's going to disrupt everything. AI is going to disrupt every industry.
Right.
AI is going to disrupt the status quo. I'm like, you say that like it's a bad thing? Is that like the status quo isn't working for a lot of people? What if we used AI to disrupt poverty? What if we used AI to disrupt prisons? What if we used AI to disrupt pollution? To your point, what if we used AI to disrupt polarization? What if you actually took these tools that are the most powerful creative tools ever and put them in the hands of people who are already creative, already resilient, already solving impossible problems with almost nothing? I think that the next model for poverty alleviation is going to be AI-driven, AI-powered, turning the people who are already making miracles happen with nothing into miracle makers with the best technology ever. And so that's what will.i.am and I are working on. And in closing, I'll just say this. James Manyika does not get any credit for 90% of the stuff that he does, because he's mainly helping people like me be more effective. And he got behind me in the work that we're doing, and we launched a campaign with will.i.am called Make Wakanda Real. Make Wakanda Real. Wakanda being in the superhero universe of Marvel, there's a country called Wakanda. It's an African country. It has the best technology in the world. They use it for good. The Black Panther, that movie from Marvel, one of the most successful movies ever, is about a country called Wakanda. So we're going to places like Atlanta, like Detroit, like Chicago, like Milwaukee, and saying, let's make Wakanda real. Why can't you grab this technology and use it for good? Why can't you grab this technology and use it to lift everybody you know up? Why can't you grab this technology and shape a better future for yourself? And it's working, and I just want to thank you, James Manyika.
No. Thank you, Vladimir. You know what's inspiring about what you're describing? There's actually now been a lot of really good work by economists. David Otter is one of those, and Eric Brynjolfsson is another, who've actually pointed out that in many cases, it's often the least skilled or the least experienced people when they're working assistively with AI who actually benefit the most.
Yes.
In fact, David Otter wrote a really remarkable essay on this might actually be a way to rebuild the American middle class. But with all of these things, I'm just curious. I mean, I know, having spent time with all of you, I know you also think deeply about how do we get this right. So with all these extraordinary opportunities, there's always complexities and risks. I know, Lila, you spend a lot of time thinking about this. In fact, it's part of your job description in many ways.
Yes.
How are you thinking about tackling and balancing and building responsibly?
Oh, yeah, it's something, I wake up and it's like my number one priority. I think much like fans talking about, my entire career, I've kind of always been an outsider. And I've brought that perspective into every single thing I've done, including all the work earlier in my career around building out the computing and internet. And the lesson I learned from that is responsibility and bringing outside voices in needs to be at the start. It's not something you bolt on. And so when I started in this role, I made it my number one priority to figure out how do you operationalize responsibility an advanced research organization like Google DeepMind. And so that could be everything from how do you make sure you're doing ethics foresight? How are you connecting with communities who you eventually want to collaborate with? Like, how do you get their voices in early into the research process? How do you build a governance structure internally where the researchers feel like it's a benefit, not overhead or bureaucratic overhead? there's a lot of work that happens into really doing this in a very authentic way, such that the end product is what you aspire it to be, and that you're continuously learning through that process. So if I just take AlphaFold as an example, kind of building off of that earlier, one of the things that we did as part of AlphaFold is we worked hand in hand with the technical researchers from the very beginning to say, what skills do we have around the table? What voices? Who are we missing? How do we go get those experts and bring them in? And it was quite an intimidating experience for the technical researchers who are don't really understand the full downstream potential of what they're working on. And it was quite a vulnerable aspect of making this culturally happen. But several dozen voices later that we made those connections, we were able to say, should we release AlphaFold AI, this advanced AI system? What could go wrong? And then what could go right? And actually, that led to a public-private collaboration with the European Bioinformatics Lab, which initially published the database in partnership with us. It also led to things like, how do we make sure that we're engaging the Global South? So some of the neglected disease efforts that are undergoing to ensure that we're taking an equitable approach to making this technology available. So, it was from the very beginning, the governance, the external stakeholders, and really this is just one example with AlphaFold, but we're doing the same thing on LearnLM, which is how we're approaching education and learning. It's how do you seek the pedagogical and the learning experts from a wide variety of countries, and so that's being built in from the start.
Right.
Bottom line, my advice for leaders, for all of us, is we know what needs to happen. So how do we put our effort in hiring the right people, building the culture, giving shining a spotlight when it happens, and giving the space when things don't go right, of how do we learn quickly and iterate? Because at the end of the day, this is a very transformational technology, and it requires exceptional care, and that requires really strong leadership.
But I think, in the case of AlphaFold, the decision I think we all made was to give open access to the data sets so people can actually use it. But I know the question of open access, open source, is one of the most hotly debated issues in this field. Anima, you've thought a lot about this, the question of open access and open models. How do you think about building responsibly? What's important to get right?
I think a lot of people may not realize how AI has been such an open source revolution, right? So even the very first neural networks that saw the beginning of the deep learning revolution was because ImageNet was there, this collection of all the images at a large scale, more than 1 million images for the first time. That was done by Fei-Fei Li, and that really enabled people like Jeff Hinton, who won the Nobel Prize today, to go try these models, right? So having open data and having open competitions is what has led the AI revolution. And now, of course, in this era of big language models, there is the worry that, if we had these giant language models in the open, bad actors can do bad things. But of course, the counterpart of this is good people can do good things with it. And it may be cheesy to say, but I do believe there's more good in the world than bad. So if you see all of that, work that would be done in the open and how these models get more robust. You saw that with the Linux revolution, right? And the same I see with AI as well. Having that in the open source means we enable everybody to not only build their own solutions, but make AI itself overall more robust. So we really have to be mindful of AI not just being one simple chatbot, right? And not something that can have a kill switch and be just shut down. It's not going to happen. It's not practical. So instead of thinking of it that way, think of just a whole ecosystem of technologies, right? And they all have to work together to make these advances happen. So how do we nurture that ecosystem while thinking of the end applications where we can focus on maybe strengthening the current laws if they're not enough, because there is now laws being discussed on, how do we think about deep fakes and how do we label them, right? That's a very specific targeted use case rather than thinking all of AI as one monolith. I think that's what we want to.
And Van, from how do we make sure we actually include everybody? I think about, take this country, for example. There's, it's such a big and diverse country, right? And how do we make sure they're in, inner cities or rural communities? How do we make sure we include everybody? How would you think about it?
You say the word inclusion now, and at this point, a lot of people start rolling their eyes because we're in a moment of real fatigue with the DEI backlash and everything else. So I just want to acknowledge on the front end that this conversation has gotten a little bit off track, because I think too much of the inclusion conversation presumes that we've got some kind of sucky communities that don't have much to offer, that kind of are deficit communities and need a bunch, right. And those of us should kind of show up and kind of do our part. And I just want to look at it slightly differently. I think AI is a baby. I think it's a baby. I think it needs a lot of help in order for it to get to where it's supposed to go. It needs help in 3 areas. It needs help when it comes to governance from government, right? What's the political system going to do to help or hurt AI? It's a big question. It needs help from cultural adoption. People think some of this stuff is creepy and scary. And so how are you going to make it culturally acceptable? And then lastly, there are a bunch of ethical challenges and dilemmas. Well, where are the resources in America to get you good politics, good cultural adoption, and good ethics? Turns out, disproportionately in communities that we sometimes overlook. For instance, let's just take the black community as a whole. The black community has a bunch of financial deficits, but we're not a poor community. We're not a poor community. The black community politically is a superpower. Right now, we have 4 African-American senators who should be a part of this conversation. We just had a black president, might have another one, we'll see. Hakeem Jeffries is probably going to be running the House next year, looks like. There are, of the top 20 cities, 10 have black mayors, 10. This is a community that's only 10% of the country. So you're talking about a political superpower that can help with governance for AI. Partnership, not pity. Culturally, I don't think I have to tell you guys this, but we're the Supreme Court for cool on planet Earth. If black folks say it's cool in South Korea. Like, we run cool. So that's going to be needed, right? Beyonce just took over country music. So look, we kind of... So I think cultural adoption, again, partnership, not pity. I think that there's a role here. And then lastly, when you talk about ethics, when you talk about values, listen, every community has a shadow side, and certainly there's a lot of shadow stuff in the black community. But our light is very light. Our light is very bright. You don't get much brighter than the black church. You don't get much brighter than Oprah Winfrey. You don't get much brighter than the civil rights tradition when you're talking about fairness, what's right, what's wrong, how do you hold people and lift them up. So you're talking about a community that is a political superpower, a cultural superpower, and an ethical and spiritual superpower that needs partners. So let's throw out that old model. I'm sick of it too. This is not about pity. This is not about you owe me. This is not about the past. This is about how do we build a better future together.